This is Cambridge IGCSE Math Specimen 2020 Paper 4 from question 6 to 11. OPQR is a rectangle and O is the origin. M is the midpoint of RQ and PT is to TQ equals to 2:1. So if we label it, this is 2 and this is 1. OP vector is small letter P and OR vector is small letter r. Part A. Find in terms of P and or R in its simplest form. MQ vector. MQ vector is here, and this line RQ is parallel to OP, so this is P as well. Also, they just said M is the midpoint, so MQ will be half of P. MT vector. We can't find it straight away from the graph, so we need to calculate it based on this small triangle here. We'll be able to get MT if we add MQ with QT. MQ is half P and QT needs to be found. Again, QP line is parallel to RO, so that makes QP R as well. They said PT to TQ is 2:1, so that makes TQ or QT 1/3 of this whole section. So TQ is 1/3 of R, but since we need to find QT in the opposite direction, change the sign in front of it and it becomes -1/3 of R. Finally, MT is MQ plus QT, so it's half P minus 1/3 R. OT vector. It's this line and it also seems to be in the middle of nowhere. Again, use a nearby triangle, maybe this one this time. If you add OP with PT, you'll be able to get OT. OP is given here, so just find PT. While PQ is R, as we've just found out, so PT will be 2/3 of R due to this ratio. The directions do not need to be changed, so the signs remain the same. Add them together and you get P plus 2/3 of R. Part B. RQ and OT are extended and meet at U. Find the position vector of U in terms of P and R. Give your answer in its simplest form. This means that RQ line will extend like this and OT will extend as well to meet here, and this point is called U. This question may sound ridiculous at first, like how are we supposed to know its position in some random space? But I got you. First of all, it's position vector of U, which means you need to find OU vector. Position vectors always start with an O from the origin. Then, okay, you might try to calculate by adding up vectors, but for this question, you need to identify similar triangles. How do you find that? Focus on OU vector and you will see that you can form an imaginary triangle here like this. And this triangle is similar to this triangle OTP, but just a little bit bigger. The important point is that we know how much bigger it is. Compare their baselines. PT is 2/3 of R, and this baseline will be just R since it's parallel to OR. So the ratio to this small triangle to big triangle is 2/3:1, and using this ratio, calculate the OU vector compared to OT vector. OT vector is P plus 2/3 of R. We found this from the previous question, and it stands for 2/3. Therefore, to find OU, you need to divide it by 2/3. And the final answer is R plus 3/2P. Part C. MT vector is 2k minus k, and its magnitude is square root of 180. The sign stands for its size. Find the positive value of k. There's a formula to find the magnitude of a vector, and it's this. Square x square y, add them together, and square root it. So let's use this formula and substitute the values. Square root of 2k squared add with minus k squared, and this equals to square root of 180. You can cancel square root on each side since they are on both sides. Expand the brackets. 4k squared plus k squared equals to 180. 5k squared equals to 180. K squared equals to 36. And k equals to 6. Question 7. Functions, also a very common question in IGCSE. Part A. Solve the equation fx equals 2g1. Fx is 2x plus 1, and g with 1 is, well, you have to substitute 1 into gx to find that out. Instead of x squared plus 4, it will be 1 squared plus 4, and that is just 5. So 2x plus 1 equals to 5, and x equals to 2. Part B. Find f inverse of x. To find the inverse, make this equation equal to y. Move this f inverse to the right side so it becomes fy. Now substitute y into fx. Then find y in terms of x. 2i equals to x minus 1, y equals to x minus 1 over 2. Since we said f inverse x equals to y in the beginning, this equation of y stands for f inverse of x. Part C. Find g of x in its simplest form. If you see two functions together like this, you substitute one function into another. In this case, you need to substitute fx into gx. So instead of x squared plus 4 in gx, it will be 2x plus 1 squared plus 4. Simplify it and you get 4x squared plus 4x plus 5. Solve the equation h inverse x equals to 0.5. Similar to part B, we can move h to the side and put it as x equals to h 0.5. Basically, if you substitute 0.5 into hx, you'll be able to find the value of x. It's 2 to the power of 0.5, so square root of 2. Part E. 1 over hx equals to 2 to the power of kx. Write down the value of k. This question is about whether or not you know the inverse law. Hx is 2 to the power of x, so it becomes like this. Well, instead of writing as a fraction for indices, if you put a negative sign in front of the power, you can write it as a whole number. So this can be written as 2 to the power of minus x. It's obvious now, k is minus 1. Question 8. The grid shows the graph of y equals to cosine x for this range. Part A. Solve the equation 3 cosine x equals to 1 in this range. Give your answers correct to one decimal place. We need to calculate it and not find it from the graph above. Make it cosine x equals to 1 over 3. X equals to cosine inverse 1 over 3. Use your calculator and it's 70.5 rounded to one decimal place. This is the basic angle. To find x, we need to see which quadrants x can be at. The value of cosine is positive, and cosine is positive at first and fourth quadrants. If it's first quadrant, it's the same as basic angle, and if it's at fourth quadrant, it's 360 minus the basic angle, which is 289.5. The final answers are 70.5 and 289.5. Part B. On the same grid, sketch the graph of y equals to sine x for this range. Yeah, we need to memorize how to draw sine, cosine, and tangent graphs. Sine graph is the most basic one, starting from 0, looking like a wave. Pay attention to its range. Sometimes it may not always be from 0 to 360 degrees. Question 9. The diagram shows a trapezium ABCD. AB is parallel to DC. AB equals to 55 meters. BD equals to 70 meters. Angle ABD equals to 40 degrees. And angle BCD equals to 32 degrees. Make sure you read this part of the question properly and observe the diagram before you start solving the questions. Part A. Calculate AD. There's a triangle ABD here. We know the length of two sides and one angle between the two sides, so we have to use cosine rho. This is the cosine rho. In case you're not sure what these alphabets stand for, it's this. Substitute the values. Simplify them. Show all your workings and the answer is 45.0, correct to three significant figures. Part B. Calculate BC. We can use this triangle BCD, but we only have one angle and one side. Well, since these lines are parallel, this angle 40 degrees is the same as this angle BDC. So we found one more angle here. This time we know two angles and one side, so use the sine rule. This is the sine rule. If this side is small letter A, the angle opposite to it will be capital letter A, and the same for other sides as well. Alright, substitute the values, rearrange them, simplify, and the answer is 84.9, correct to 3SF. Part C. Calculate the area of ABCD. You might want to find the area of this whole trapezium, but it's easier to calculate the area of each triangle and add them together since we have all the information that we need. The formula to find the area of triangle is this, using trigonometry. A and B are the sides, and C stands for the angle between the sides A and B. For triangle ABD, it's half times 55 times 70 times sine 40. And for triangle BCD, it's half times 70 times 84.9 times the angle DBC, which is 180 minus 40 minus 32. Add them together and the answer is 4,060 meters square. Part D. Calculate the shortest distance from A to BD. Shortest distance means it's perpendicular distance, like this. I'm gonna call it as the height of this triangle. You know that there's another formula to find the area of triangle, which is half times length times height. We know the area of this triangle, we just found it, and the length is given here, it's 70 meters. So we can make a new equation, half times 55 times 77 times sine 40, the exact formula we just used to find the area of the triangle, equals to half times 70 times the height. Simplify each side first and rearrange the equation in terms of height. You'll get 35.4. By the way, if you haven't yet, please subscribe to my channel and share my videos with your friends and classmates. Question 10, Part A. Show that the volume of a metal sphere of radius 15 cm is 13,140 cm cubed, correct to 4 significant figures. The volume V of a sphere with a radius r is V equals to 4 over 3 pi r cubed. It's a simple question, just substitute 15 into r of this formula, and you don't have to memorize this formula, they always give it to you. Part B. The sphere is placed inside an empty cylindrical tank of radius 25 cm and height of 60 cm. The tank is filled with water. Calculate the volume of water needed to fill the tank. Alright, you will need water to fill up space except where sphere is located. So subtract the volume of sphere from the volume of cylinder. We know the volume of sphere from part A, but we need to find the volume of cylinder. Okay, this formula should be memorized. It's the area of base, this circle, multiplied by height of the cylinder. So in this case, it's pi times 25 squared times 60. Subtract 14,140 from it, and it's 104,000. The sphere is removed from the tank. Calculate the depth, d, of water in the tank. Don't forget that the volume of water did not change. It's still 104,000, but the height obviously decreased. So we form a new equation of the volume of water in this part of the cylinder. Pi times 25 squared times height equals to 104,000. Rearrange it in terms of height and use your calculator. The answer is 52.8. Part C. The diagram below shows a solid circular cone and a solid sphere. I've seen many questions similar to this, so make sure you completely understand how to solve this. The cone has radius 5x cm and height 12x cm. The sphere has radius r cm. The cone has the same total surface area as the sphere. Know that r squared equals to 45 over 2x squared. Again, they have given you the formula of surface area of a cone and a sphere. 5-mark question, but don't worry, I got you. In case you have no idea where to even start, since they just said show this equation, remember that they gave you these formulae. What are they about? Surface area. So find the surface area of this cone and a sphere, and everything will sort out on its own. Starting with a cone. A equals to pi times r, which is 5x here times L. Now L is not 12x. L stands for the slant height, this part, and 12x is just the height. We have to find L separately, and we can do it by first identifying that there is a triangle here. Use the Pythagoras theorem to find the slant height. (13x). This just stands for the curved surface area, and a cone is made of a curved area and a circular base. So now you need to find the area of this circle and add them together. A lot of people make mistakes in finding the surface area of a cone, so be careful. This is the final total surface area of this cone. For the sphere, A equals to 4 pi times r squared. R is just r for this. Okay, and they said the cone has the same total surface area as the sphere, which means this equation equals to 4 pi r squared. We need to show that r squared equals to this. Simplify them and you'll get 45 over 2x squared. Last question, question 11. A curve has equation y equals to x cubed minus 6x squared plus 16. Part A. Find the coordinates of the two turning points. What should we do to find the turning points? Differentiate the equation. X cubed, so multiply 3 with x, and minus 1 from the power, so 3x squared. Minus 6x squared, so multiply minus 6 with 2, and minus 1 from the power, so minus 12x. 16 doesn't have any x behind it, so it just disappears. Now, to find the turning points, you need to make the differentiated equation equal to 0. Stat dy dx equals to 0. Now it's factorization. Take out 3x from each of them, it's the common one. That makes this. Okay, so the x coordinates are 0 and 4 because if you put 0 here, it makes the equation 0, and if you put 4 here, it again makes the equation 0. We need to find the coordinates of the turning points, so substitute these values of x into this equation of the curve. For 0, you get 16, and for 4, you get negative 16, and that's the answer. This type of questions follow the exact same pattern every time, even for Add Maths, so as long as you practice many times, you'll get it. Part B. Determine whether each of the turning points is a maximum or a minimum. Give reasons for your answers. The most accurate way is to find the second derivative of the equation of the curve. You do that by differentiating dy dx one more time. That will give you 6x minus 12. Now substitute the value of x into this equation. First, 0. You get negative 12, and if you get a negative value, it means that it's a maximum point. Try substituting 4 to x since it's the second x coordinate we just found. You get 12, which is a positive number. So this coordinate is a minimum point. Give valid reasons and you're done. Thank you so much for watching and all the best to you guys. Leave some comments to let me know if it was helpful, and subscribe and like this video if you want to watch more videos like this. Stay safe and God bless you guys. Bye!